Welcome to my podcast, Why Didn't Anyone Tell Me This? With my guests, we are discussing health issues with an emphasis on reproductive health, answering questions you may have, and debunking some of the myths around our health. And today, it's very exciting. I'm talking to David Wood about the abolition of aging. And David is someone who's a little bit to the side of what my normal guest would be talking about. So it's going to be very exciting to talk to David today. So, David spent 25 years as a trailblazing pioneer of the mobile computing and smartphone industries and envisaged what the future might look like, and then worked with many colleagues as part of a large ecosystem to bring that vision into reality. He sits on a number of boards, including the Institute for Ethics and Emerging Technologies and the Longevity Escape Velocity Foundation, and he chairs the world's largest meetup organization with a focus on future foresight called London Futurists. And we're going to talk about them today. David regularly gives keynotes or leads workshops on aspects of envisaging and shaping the future. Now, David has written many books, and I must admit I haven't read all of them. He's talked about smartphones and beyond, transcending politics, vital foresight, sustainable superabundance, the Singularity Principles, and the Abolition of Aging. And that's the one we're going to talk about today. So, hello, David.
Great to be here, Joyce. Looking forward to a fine discussion.
Yes, I think we will. So, I first met David on a TV program where we were discussing genome editing. And at that time, I'd been part of the Nuffield Council on Bioethics working group on genome editing. And we had written a document about our findings. And to be honest, I've always been rather cautious of the procedure. I'm very concerned about the safety, and I'd always thought about where this technology would take us in the future, excuse me, especially with regards to fertility and reproduction. But David had a very different view. And I had to admit that when I was on the TV program with him, I did not agree with a lot of what he said, but I was fascinated by what he said. And since then, I've attended one of David's futurist conferences. And again, I just loved it, hearing people talk about things that, to be honest, made me feel pretty uncomfortable. But I did meet some of the world leaders in transhumanism, and I just find it absolutely fascinating. And we did a webinar together a few years ago with Jamie Mertz, who has written a book that I absolutely loved called Hacking Darwin. And for the last few years, I've invited David to give one of our final talks on our MSc program. We have a module called New Technology and the Future of Reproductive Science. And my students have absolutely loved David's talk. And they've said it's one of the best talks of the whole MSc. So I want to chat to David and talk about some of these really interesting and maybe a little bit out there topics that David discusses. So before we start talking about your book, David, can you explain a few terms, as I think for many of the listeners, they will be very new. And when I do a talk on reproduction or fertility, I always end actually by talking about transhumanists. And I normally ask my audience, does anyone know what this is? And I think I've had only a couple of hands go up in all the hundreds and hundreds of people that I've asked. So let's start with that. What is transhumanism?
It's the view that there's a much better future ahead of us in which we are living lives significantly better than anybody has lived throughout history in terms of longer lives, more intelligent lives, happier lives, more collaborative lives, more creative lives. And how are we going to get there? Not via blind evolution, which has produced something which is both wonderful and terrible. Blind evolution has given us angelic characteristics, but also diabolical characteristics. Well, from now on, we're going to use, wisely, carefully, intelligent design. That's what transhumanism envisions. And the word trans there, some people say it means transcend, which means we're going to leave behind some of the drawbacks, the limitations of the human nature we have inherited from biological evolution and the culture and the psychology and the philosophy, which has taken us a certain amount of way forwards, but can now hold us back unless we transcend it.
Thank you. That's excellent description. And I've heard you talk about the four supers of transhumanism. Can you explain that?
So, this is a useful way of describing transhumanism. We talk about super longevity, which means not just living well to the age of 85, which is what most people in the Western world seem to hope for, but we can live well indefinitely, hundreds of years, thousands of years, if we wish, not just with an extended life, but with an expanded quality of life. Then the super intelligence, which means leaving behind many of the negative aspects of our thinking which people call cognitive biases, or sometimes people call stupidity, individual stupidity or collective stupidity. Things that sort of were useful in evolutionary timescales, but which are very dangerous in the much more powerful, much more connected world of today. That's superintelligence, transcending our rationality. Super happiness means leaving behind our evolutionary instincts, often to egotism, to depression, to envy, to dominating and abusing power. So we can look forward to having a richer all round happiness. And then there's super democracy, which means that our relationships bring out the best in all of us rather than we abuse each other through deception and so forth. So, all of these things are possible if we wisely take advantage of some of the fascinating and fast moving new technologies that are within our grasp.
Thank you. And so you run the London Futurists. So tell us a bit more about them and tell us what a futurist is.
A futurist is somebody who thinks it is worthwhile to seriously contemplate future scenarios. Some people say, well, future is just for entertainment, and we all enjoy occasionally going to the movies and looking at some wild ideas of what the future may hold. That's useful, but sometimes we've got to be more careful at distinguishing science fiction scenarios which can never come true from science based scenarios which may well come true, even though they are surprising. So a futurist tries to work out which of these scenarios are credible. Secondly, futurists try to work out which of these scenarios are desirable, bearing in mind that our first reactions are often misleading. Sometimes we have a three-letter reaction, which is yuck, this is terrible. And sometimes we have another three-letter reaction, wow, this will be wonderful. But in both cases, these reactions can mislead us because they are based upon intuitions from the past, and we sometimes need to be more thoughtful. So we work out which scenarios are desirable, and most importantly, we want to work out what we can do about it. Not just to passively wait for these scenarios to come, but what can we do to accelerate the desirable futures and to delay or prevent and steer away from the undesirable futures? So that's what a futurist in general does.
And your London group meets very regularly. You're very, very active, aren't you?
We've been running for 15 years, since March 2008. Typically at least one meeting a month, sometimes more often. These days we tend to meet more often online than in the real world, but people keep saying, David, let's have a real world meeting. So there are one or two in the calendar. And in addition, nowadays we do podcasts like yours, Joyce, but slightly different, where we look at the possibilities of exponential disruption. So we do a podcast once a week, which I encourage people, once they've listened to all of yours, to find some time to listen to some of ours. That's the London Futurist podcast. And then there's a newsletter which comes out several times a month on my views on some of the projects and meetings that are going on around the world, not just the London Futurist meetings, but others that I consider to be interesting to the readership.
Excellent. While we're talking about futurists, let me bring this in now. So we had some conversations about the Black Mirror series. It's something that certainly my kids don't like to watch many programs with me, but they do watch Black Mirror, and they're pretty. Some of them are pretty out there, and I think what I love about them is they really make me think. They make me think about, well, this could be possible, that could be possible. And I always think it's important to see how in television and in film and in other sorts of media, we are portraying different scenarios, such as for me, reproduction or the future or whatever it may be. But what's your view? Have you I think you've seen some of the Black Mirrors. What do you think about it?
A great piece of TV, usually. I haven't watched the most recent series yet. People are giving mixed reactions about it. Well, I shouldn't be too dissuaded by these reactions. I should make my own mind up, and I will in due course. So I've watched probably two-thirds of all the earlier ones, and some of them are really good in the sense that they paint a picture which we ought to think about. I'm thinking, for example, of one called Be Right Back, in which, spoiler alert's coming, sorry, a person is killed in a road accident at a relatively young age, but there is an image made of him for his wife of the kinds of things he might say, and in due course there is a robot made that resembles him and looks like him, and he's not quite the real person, but he has sufficient characteristics. Something like this is probably going to be available not too far into the future, at least the audio conversations with our loved ones. Do we want this or do we not? And the program leaves it nicely balanced. You can see some of the upsides and you can certainly see the downsides. So that's one example. There's another episode I remember in which it turns out that two people are being evaluated for their possible romantic compatibility over a long period of time. And this all happens by the software creating virtual realities and watching how these characters react in long virtual reality scenarios of weeks, months living together. And this all happens in real time within seconds. And at the end, the software says, right, you two are a good match for each other. Well, we don't quite have this yet, but there's big business software that picks people to spend romantic time together or other intimate time together. So, yeah, I think it's great that these things are creatively raising questions, but we need to couple that creativity with our own critical analysis, which is what we try to do in our London Futurists meetings.
Excellent. Yeah, I think that some of the Black Mirror that deal with tech, I sit there and think, wow, that's an amazing idea, but I could really see that happening relatively soon, even in my lifetime. So I think they're important issues to think about. And before we get into your book, two more definitions for the listeners: humanity plus, which I see a lot, and the singularity.
Humanity Plus is the name of an organization which used to be called the World Transhumanist Association, set up in 1998 by, as it happens, two people who were in Britain at the time. And it's evolved. And the word transhumanist has mixed views. People sometimes say, oh, it's a bit geeky, it's got bad connotations, let's find a new word. And so the organization said, let's rebrand ourselves. This is more than 10 years ago now, as Humanity Plus, which says we're going to have all the good aspects of humanity and enhance them and leave behind some of the negative aspects, the bad things that we do to each other and to ourselves. So that's an organization, Humanity Plus. And sometimes instead of talking about a transhumanist future, for variation, I'll say, let's have a Humanity Plus future or a Human 2.0 future. Then there's the concept of the singularity. And this could take us a bit longer to get into, but basically it's the idea that we humans will be overtaken, perhaps quite soon, by a new sort of species, namely artificial intelligence. And we will become the second most intelligent species on the planet because AIs, which today can outperform us in many narrow fields, in the future it will outperform us in every field of thinking. It will be able to anticipate all that we are thinking of, and if it wants, it will be able to outmaneuver us. And just as we humans, we are the ones who are determining the fate of currently the second most intelligent species on the planet, the chimpanzees, the gorillas, and so forth. The fate of gorillas and chimpanzees is not in their hands, it's very much in our hands. Well, in the future, after the singularity, if we're not careful, we will be entirely at the whim of what the artificial general intelligence decides to do. And it may not be particularly interested in us, just as we humans are not particularly interested in, for example, ants. When we are building a new shopping complex or a new university campus, and there are some ants in the way, we don't think too much about extinguishing these ants in order to make room for us. In the future, an AGI, if we're not careful, might lead to a much shorter, a much smaller number of humans still around. The probability is that such an AI might keep a few of us around for curiosity, but it would say we don't need 8 billion of them. So that would be a negative singularity. And the whole point of the futurist work is to ensure that, on the contrary, we have a positive singularity in which this AI helps us, wishes to help us reach that vision which I previously outlined, the humanity plus vision.
Excellent. So yes, well, I always like to be positive. I think lots of people are worried about AI, and we've just had this week the Hollywood actors, and some of the writers strike because they're worried about various things. But one of them that I heard was AI, and I heard one of the authors say, AI can write a book in minutes. And when you spoke to our MSc students, you showed them. You did a great thing. I think it was Shakespeare writing a poem about IVF. Was that right? Is that what you did?
I think so, yes. And about a couple in their journey with IVF, and it seemed to be not only technically accurate, it seemed to get a lot of the emotional or relationship issues correct as well. It didn't say, well, this is bound to be successful, and if it's not successful, then it's a failure. It's going to say, well, you have to figure out together what the right approach is, except it said it in beautiful Shakespearean language instead of my mangled 2023 academic British.
I was quite taken aback. It was quite brilliant, actually. Yeah. So but it does make me feel a little bit scared. But let's go on and talk about the abolition of aging. So, when you talked to my master's students, you looked at what were the main causes of death about 100 years ago and how that's changed now, and how we can think of that with regard to aging. Do you want to tell us a little bit about what you said?
So people used to think that various diseases were facts of life, and there was nothing much you could do about them. What tended to kill most people for most of history were things like tuberculosis, diseases of the intestines, the digestive systems, gastroenteritis leading to diarrhea, influenza, pneumonia, malaria, and so on. And there was nothing much you could do about them. You could try to pray, you could try to keep yourself hygienic, but nobody knew much about the germs. And if they did know about germs, there was still nothing much that could be done about them. So that was the main causes of death 100 years ago. And these diseases still kill far too many people, but it is, at least in most developed countries, a fraction of the number of people die from them. As a result, instead of the average lifespan being somewhere between 30 and 40, the average lifespan is now around the world more than 70. But similarly, people still think there are other diseases which we can't do anything much about. That dementia, cancer, heart disease, diabetes, stroke is bound to get to us all sooner or later. And in particular, people think, well, aging is bound to come sooner or later. But I want to make the case that just as the scientific progress in the last 2 centuries has performed wonders against the common causes of all these infectious diseases, namely germs, just as that has provided us solutions with antibiotics and vaccinations, in a similar way, the technologies that are rapidly improving today, artificial intelligence, biotech, nanotech, and so on, this will allow us to deal with all these other diseases, which are best characterized as age-related diseases. And when I say that, I realize that some young people do get cancer. There are some rare cases of early onset dementia, but in almost all cases, these diseases are accelerated the older we get. So if you say to somebody, you don't want to get cancer, why don't you stop smoking? That's good advice. But even better advice is, you don't want to get cancer, hey, stop aging. And I say it's better advice because numerically that's significant, but it is now practical advice because within our grasp there are treatments, a suite of treatments, not just one pill, a whole variety of things we will probably need to take, but they will have the effect of resetting the damage that's in the cellular and intercellular levels of our body so that we'll be rejuvenated. And that will allow us to have much less incidence of these diseases. And if we do get them, they will be much less likely to kill us. That's the vision.
Thank you. And in your book, you talk about the rejuveneering project, and that it's not going to be a simple thing, as you've said. It's not going to be one pill or one thing that we have to do. So tell us more about that.
Well, actually, the solutions to the infectious diseases were complicated as well. We can now look back with the advantage of hindsight and say, hey, tuberculosis is no longer anything like as bad as it used to be. But actually, some of the early treatments of tuberculosis did not work. Even the person, his name was Koch, the German scientist, Robert Koch, he discovered the bacillus that was responsible for tuberculosis, but the first two things he promoted as cures for tuberculosis were nothing of the kind. They arguably made things worse. So he became a controversial figure, despite his brilliance as a scientist. Later on, the first time antibiotics were introduced to deal with bacteria, the first time antibiotics were introduced to deal with tuberculosis, they only brought a temporary respite, and the disease came back in a much more terrible, malignant manner. So people said, this hasn't worked at all. It turns out that in order to treat TB, what you need is a combination of ideally two, ideally actually three different antibiotics, and that's what defeats the disease. So, in a similar way, we can talk in general terms about the vision of dealing with aging. In reality, we're going to need to deal with a whole bunch of different hallmarks of aging, and we can break that down and we can become more scientific and technical here. But there's a bunch of things at the cellular level, the mitochondrial dysfunction. Mitochondria are the little energy generators inside our cells. They've got their own DNA. It's not the DNA of the nucleus. As we get older, they become dysfunctional. There are senescent cells, which are cells that become dysfunctional. And normally, when the body's younger, these senescent cells are recycled nicely by mechanisms in the body. But as we become older, these recycling mechanisms fail. And so the body gets an increasing number of senescent cells, which are leaking chemicals to the environment inside the body, which are causing increasing damage. So that's two examples of damage. And some people count 9 types of damage, or 7 types of damage, or 12 types of damage, and so on. It's an open question as to how many of them are fundamental and separate. But what is important is that we have a vision in each case of projects which will help us undo the damage. So, for example, on the senescent cells, there's a whole branch of things called senolytics. In fact, 3 different types of senolytics, which has the ability to trigger the body to recycle more effectively again and deal with this problem. So in each of these cases, the damage repair will help us be younger again. A simple example, which everybody can, I think, sympathize with, is occasionally some of us go to the dentist, and at the dentist we have a hygienist who scrapes off layers of plaque, which some of us are more prone to get on our teeth. And as a result of having less plaque, we are less prone to gum disease, and because we are less prone to gum disease, as it turns out, we're less prone to other diseases throughout the body, including diseases of the brain. So that's a relatively well understood cleaning mechanism, and I envision that in the not too distant future, we'll be going to rejuveneers or medical practitioners of various sorts who will clean out other parts of damage, the senolytic cells and the other types of damage as well.
I do a lot around new tech, mainly in the reproductive health area, but this is going to be big business for sure. I think all of us want to abolish aging, and we all want to stay young and fit and healthy. So how do we work through this? How does the average person understand whether a new technique or a new supplement or a pill or potion is really valid, or whether it's something that's just really a con. I see more and more of the startups with some of the new health tech, and they sound so convincing when they're pitching about their product or their treatment. And if I'm in the audience, I always say, where's your evidence that this is actually going to help? So finding evidence and doing clinical trials to see that your therapy or treatment is going to improve the person's health takes money and it takes time, and it doesn't really get done. Even in the fertility field, that's really rich financially, we have a big hole in the clinical trials that should be done, and treatments are offered to many people. So how would we know when we're sitting at home and we see an advert on Facebook for, you know, an example for women is every day there's serums and things that are going to make you look younger, and if you do this to your face and go and see this person and they'll peel it off and do this, there's crazy things for women to look younger. So how do we how do we get through this noise and really know if something's really valid?
I think we could talk about this subject in its own right for at least an hour. It is a complicated area. But I will give a few simple answers. First, none of us can work out this by ourselves. We will each of us be misled because however much we already know, we can easily reach the limits of our current knowledge. So how can we solve this? Well, we have to get involved with the right community. This is how science has progressed, and science has a community of scientists, and there is peer recognition. And generally, you think, well, these scientists have got a better reputation. Even then, they must still submit their work to various disciplines, and other people must be able to replicate it and challenge it. And so there is a scientific community which gradually produces work that the rest of us can trust. Although even then, there are sometimes conflicting motivations. Some people become very much devoted to their own ideology, and there are scientists who stand to make money because they have spin-outs which might subvert their motivations in some cases. Hopefully not too many. So it is complicated. So let's connect with the communities where people are already doing investigations. So that's part of what we try and do in London Futurists, though we're not specialists in that. I would point to, for example, the Forever Healthy publication, which comes from a German entrepreneur, Michael Greve. So he's made lots of money in the past, not out of health, but out of the German equivalent of lastminute.com and other things. So he does not need to make money, and he is not trying to make money out of this at all, but he has commissioned lots of research into various of the elixirs, various of the compounds which other people are promoting. And his research normally says, right, it's a mixed bag. Here are the times and circumstances and conditions under which this compound is probably good for you. And here are circumstances in which, because of your personal issues, it probably isn't so good for you. And if you do take it, here are some considerations on dosage. And these aren't produced as the final word because knowledge is changing the whole time, but they are the best tentative conclusions so far. So we have to each for ourselves figure out what publications, what sources are more reliable than others. So I'm pointing out here what Michael Greve has covered. I give some pointers in the various books I've written myself. We're talking today about the Abolition of Aging, where I give some pointers and clues, but there I'm still quite skeptical about many things. I say it's often too early to tell. There is a more recent book, which we might briefly mention. It has some of the chapters from my book, Abolition of Aging, brought up to date and combined with ideas from one of my colleagues. His name is Jose Cordero, Spanish, born in Venezuela, studied at MIT. That's the other Cambridge, Boston, as opposed to where I was, Cambridge, England. And the two of us have brought some of our ideas up to date in a book that's just come out in English. So I think I ought to mention it. That is The Death of Death, a little bit more of a provocative title. But in there, we do talk about Bridge 1, which is where we are now. Bridge 1 being what we can do to make it more likely that we will live a bit longer and be ready to take advantage of more powerful technologies. Bridge 2, more substantial reprogramming of our biology, which may become available 10, 20 years from now.
Thank you. And in your book, your advice is be ready to revise our opinions and options as new evidence comes out. And that's what I tell my students the first day they arrive. As a scientist, we have to revise our opinions of everything as new research comes out. So we should be questioning all the time and be ready to change our mind and stand up and say that. And I wanted to delve into a few of the topics that you've gone into in your book, such as supplements and the genetics of this. Let's talk about the uncontroversial one. So you have written a section about lifestyle factors and how we might need to navigate the vast amount of conflicting advice that we get, which is normally overwhelmed by the fact that people are trying to sell something. So, for example, even in a field like the menopause, the doctor's advice normally is first look at your lifestyle factors such as your diet and your exercise and your sleep, etc. But we are bombarded by people that want to sell us menopause hair shampoo, face cream, menopause tea. It's gone to the extreme that people put menopause in front of anything because they want to sell it. So aging, certainly, as I've mentioned, face creams, lotions, potions. So how do you feel about lifestyle? What advice would you be giving people to be looking after their lifestyle?
Well, I try and change my lifestyle in various ways. Sleeping is important for living longer. So make sure that I get enough sleep. And if for whatever reason I don't get enough sleep in the night, I don't mind taking a nap in the afternoon nowadays. And that gives a chance for the body to recover. So I think it is important to get good sleep. Another finding, which I think is well established, is that it helps to have intermittent fasting. In other words, that we don't eat as much as we want all the time. We don't always just eat 3 full meals a day, but in various ways we might have several days in a week. This is my own practice. 5 days a week, I tend to eat much less. I do eat something, but it's about a quarter of the recommended daily calorie intake, and I make sure in that there are all the essential minerals and supplements. So I do that in part because there is evidence that it pushes the body into a recovery mode. There's autophagy, in which parts of the body says, hey, we're short of resources, let's do some repair, rather than, hey, we've got plenty of resources, let's just be extravagant, just to put words into the mouth of what some of the chemicals in our body is doing. So there is this intermittent fasting, but that's also a complicated subject because there's different ways of doing intermittent fasting. Some people go 16 hours a day without eating. Other people, as I say, have days in the week in which they eat less. And I think it does depend, again, on our individual metabolism. It also depends on our individual psychology and our social lives. And some people may find that because of their work, they're not able to do this. So each of us has got to find what works for us and stick with it for a while. Another very important thing is having a good set of social relationships. Loneliness kills. Loneliness is related to having a shorter lifespan, quite significantly. And it's related to the fact that somehow our immune system weakens when we're not having vibrant, engaging relationships with people. I know you can't get these vibrant relationships with people just by scrolling through Facebook posts. There's nothing wrong with having some interactions online, but they've got to be personalized and they've got to be real. And some of that triggers the body into keeping us partially young as well. So these lifestyle matters are important. There's probably a few others. Yeah, exercise. It is important to stress ourselves on a regular basis. So I walk almost every day for an hour, reasonably briskly. And it helps because it allows me to plug into whichever audiobook or podcast I happen to be listening to at the time. So we have to manage our lives for that extra bit of life. But if we're serious about living much, much longer, that's not enough because that may give us maybe 5 or maybe 10 years extra life expectancy in extreme cases. Far more important is to bring forward the time at which longevity escape velocity, that's the treatments which will allow us, in principle, to live indefinitely, we should bring that forwards. And if that's maybe 15 or 20 or 30 years in the future, it's far more important that we can bring that forwards. And I think that by the right actions, by the right investments, by the right research, by the right collaborations, we can bring forward the date in which that occurs. And so more of my effort is on that than on just my own lifestyle.
How will that look? What sort of things are you think bubbling under that's really going to be the game changer for aging?
There's lots of interesting things happening. One of them is epigenetic reprogramming. So epigenetics is a booming field. It used to be thought that genes were genes, but although we have the same genes in each cell of our body, different cells produce different proteins. Why? Because in different cells of our body, there is different activity from the genes. The DNA is covered in some aspects by methyl groups, that's CH3 groups, which prevent that part of the DNA from being active in these cells. But over time, the epigenetics, that's that skin on top of the DNA, degrades. And it's a fairly constant thing. So over time, some of our skin cells may start producing proteins that are completely inappropriate for skin, and vice versa. And so the various parts of our cells aren't so young anymore. But it has been discovered there are mechanisms to reprogram the youthfulness of cells. We knew this was bound to be the case in any way, because parents who are in their 20s, 30s, 40s, and 50s can give rise to cells in the next generation which are 0 years old. They are epigenetically cleansed. So there are mechanisms in nature. And in 2012, if I've got the date right, Shinya Yamanaka, a Japanese scientist, was given a share of a Nobel Prize. I probably got the date wrong, I apologize, but what he did was he shown that 4 factors introduced to a cell could do this reversal of the epigenetics programming. Now, we don't want to reprogram the cells all the way back into their pluripotent state in which they no longer know that they're a skin cell or an eye cell or whatever. That will give rise to carcinomas or some other kind of growth. We want to partially reprogram them. And this is what's really exciting. This is what's brought in a lot of investment from people like Jeff Bezos, one of the richest men of the world, and other billionaires. They are investing in a group called Altos Labs, which Shinya Yamanaka, this Japanese scientist I've just mentioned, he is an honorary advisor, so he's not being paid for that. He's a scientist, a true scientist in that sense, but he is giving advice. And there are groups around the world, in Cambridge in the UK, in California, in Germany and elsewhere, which have brought lots of cutting-edge scientists to look at how does this partial reprogramming work. And there is signs that as the cells are made younger again, many of the other hallmarks of aging are dealt with too. So in some sense, this might be a more fundamental hallmark compared to some of the others. It's to be determined. So that's one way in which there's been a lot of progress very quickly. I should also point to the application of artificial intelligence in the field of drug discovery. We are often celebrating the progress with technology. One area in which progress has gone backwards is how long it takes and how much money it takes to bring a drug all the way through phase 1, phase 2, and phase 3 trials. This has roughly doubled every 8 years since the 1950s. It is now a horrendously expensive process. And the good news is that AI shows signs of reducing this in multiple ways, which we could look at. So there are companies such as In Silico Medicine, headed by Alex Zavaronkov. You can read about him in a couple of the London Futurists podcasts, among other things, what he is doing to increase the chance that a drug that goes through phase 1 will also go all the way through to phase 3, and therefore increase the likelihood of a drug being a success. Not just an existing drug, but their system can also generate ideas for new chemicals that have never existed before. It can figure out in advance, a bit like generative AI comes up with new pictures that have never existed before. Similar programming can result in AI that knows a heck of a lot about chemistry and biochemistry can come up with new molecules, which, if they were created, have a good chance of interfering with various disease pathways to rejuvenate parts of the cells. So they're making fast progress there too. So that's just two: the partial reprogramming using some of the Yamanaka factors and the use of generative AI to accelerate and improve the likelihood of successful drug discovery.
Exciting times. I think when we talk about aging, I think it would be wrong not to mention the telomeres. So these are the areas at the end of our chromosomes that, as we age, they become shorter, and they can help figure out the age of someone, but also they are definitely involved with aging. So, did you want to tell us a little bit more about telomeres and also the work of Liz Parrish, who you mentioned in your book?
Yeah, this is fascinating as well. And telomeres are another one of the separate hallmarks of aging. Sometimes they're described as similar to what we have at the end of our shoelaces. There's a little aglet, I think it's called, a little bit of plastic that stops the shoelace unfraying. So every time a cell divides, it turns out that almost always the bit at the end, the telomere, is shortened because the copying mechanism can't copy it all. And after a certain number of times, between 30 and 50 times, the telomere has become so short that it is no longer possible for that cell to keep on dividing. This is called the Hayflick limit, after Leonard Hayflick, who discovered this in, I think, the early 1960s. So if cells are no longer able to divide, it means that our stem cells are no longer able to produce the new cells that we need, new blood cells, or when we have a wound, we need new cells to repair the wound, and so forth. Now, the body does have mechanisms in some cases to extend the telomeres again. There's an enzyme called telomerase. And the idea of people like Liz Parrish, there's also another scientist called Bill Andrews, who have looked hard at this, is to use this enzyme telomerase more often so that more of the cells in our bodies are rejuvenated in that sense. Now, people have been worried. They have said if you have too much telomerase, you risk getting more cancer because telomerase, the fact that the whole telomeres are not copied all the time, is sometimes thought to be a mechanism to prevent cancer. But there is an increasing amount of research that says actually it's more complicated, and that if you have better telomeres, you are actually less likely to have cancer. Now, Liz Parrish has put her money where her mouth is in a very real way. She has become patient zero of a trial which now has more people in it, thankfully, which takes a viral vector that incorporates telomerase into more parts of our body so that the telomeres throughout her blood and other parts of her body have become longer. And by some measures, she is 20 years younger a few years after this than she was before. Now, n equals 1 is not a reliable way to conduct any scientific test. There can be many other reasons why somebody looks younger now than before. If you've got a new lease of life, whatever, you can look younger. Liz Parrish definitely looks young and impressive, and she also took another genetic supplement, also programmed in at the same time to repair aging muscles, and she looks strong and healthy. Well, now the science tests are proceeding. Liz Parrish has a podcast of her own, so I encourage your listeners to track that down. Her company is called BioViva Sciences, and they are applying this now to other patients, not just to see whether they look younger, but whether it can actually deal with specific diseases such as dementia, such as other chronic diseases of aging. And it is very exciting and very encouraging. So you're quite right to draw my attention to that. But this just goes to show there is a heck of a lot going on. There are lots of
Yeah.
independent lines of research which are promising. They won't all succeed. Many of them will turn out to only take us so far along the curve. Many of them will have side effects, like some of the treatments for TB that I mentioned turned out to be not so promising as people had initially hoped. But that's what engineering is about. It's figuring out the right combination of treatments so that we will no longer be victims of the dementia, the downward spiral, the incontinence, and all the other drawbacks of aging.
Yeah, it's as you said, there's going to be many, and we've got to try and wade our way through this soup of all the new tech. But we need to listen to people like you who are really, got your finger on the pulse of this. Something that's not quite so high tech, but is big business, is the supplement field. And you mentioned this in your book, and I've never taken any supplements until recently. I was always arguing against it. I did a biochemistry degree. I was always told that we've got to be very careful with things like vitamins and antioxidants. They are powerful, and if we can certainly overdose on some vitamins, and I'll come back to what you said in your book about that. But I recently, I have, in the last few years, I've started taking collagen. I read up on it. I wasn't really that bothered about what I'd look like. It was mainly for my joints. When we met, I told you I've been having sore knees recently. I do a lot of sport. I do a lot of jumping sport. And I run. So I was a bit concerned about those. And I didn't actually notice any effect on my joints, but people said I look totally different. Loads of people, everyone says, "What are you doing? You're looking a lot younger." And people thought it's because I've been cold water swimming a lot, which I think really helps the circulation, etc. So I don't know. I am still taking it, but then since I've seen you for my knees, I have now had a steroid injection in my knees, and I only had it done 4 days ago. I've got new knees. I've got no pain. I feel totally mobile. So I think there are some things that we can do on a much cheaper level than something like trying to extend our telomeres, etc. But as you said, you talked about some experiments in your book that have been done where people were taking high doses of vitamins and antioxidants. And in some of the studies, they actually died younger than in the control group, especially relating to heart disease and cancer. So can you tell us a little bit more about your views on supplements?
Well, the first thing I would say is that we are all different, and somebody may have sore knees, and one person has a good treatment for sore knees. It works for them. It doesn't mean it's the right treatment for somebody else. I almost had steroid injections for my knees a while ago. One doctor said, well, maybe this is the best approach. And another doctor said, no, 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 you should go and see a physiotherapist for a while. And I did find a physiotherapist who gave me various exercises, and my knees are much, much better as a result. So I managed to not have that treatment, but I'm not saying it's a wrong treatment in every case. There may well be cases when it is the right treatment. Now, the cases of vitamin C, there was a movement for a while. There were lots of books inspired by a very brilliant man, Linus Pauling, who is, I think, the only person to have got a Nobel Prize twice singly. There are people who've got shares of Nobel Prizes twice, but no Linus Pauling. So, by some measures, if you look at what he did in his career, some people have said he could have won the Nobel Prize 5 times for the amount of brilliant work he did and discovering the structure of the chemical bond, and I forget what else he did. I've written it all up in the section in my book, The Abolition of Aging. But he had the idea that vitamin C was the best solution to avoiding cancer. And he got contacted by some doctors who persuaded him of this. But other people looked at the evidence and said, well, frankly, this is not a proper double-blind test here. You are selecting people to treat because you think they're more likely to fare well. You're doing this subconsciously, perhaps, not him, but the other doctors who were involved. So other people were more skeptical, and Linus Pauling went to his grave saying we should have more and more and more vitamin C. And his wife, sadly, died of cancer, and he said, well, we should have started vitamin C earlier for her, and I think he died himself of that too. But it turns out the people have done experiments, careful measurements, and people who take high doses of vitamin C actually often die of other causes. So we should avoid, first of all, hero worshipping. Just because somebody might have won 5 Nobel Prizes for the quality of the good work, it doesn't mean that they're going to be always correct in another field too. That's what science is about. You don't just say, hey, Einstein is Einstein, he's bound to be correct. I mean, Linus Pauling's got that wrong, and he got several other things wrong too. So that's why we need the whole scientific community. But on the other hand, sometimes the scientific community is wrong as well, or they are slow to adopt. The medical practice for a long time didn't think much about washing hands carefully. For a long time, people said superficial hand washing is all that's necessary. Gentlemen surgeons don't cause diseases in their patients. And it turned out to be horrific. And the people such as Ignaz Semmelweis famously, who did some experiments and had evidence that washing your hands in chlorinated lime reduced the incidence of various child bed fevers. He was ignored and resisted by the medical establishment for a while. So sometimes the medical establishment is a bit slow to adopt before they finally wake up to the evidence. So again, it's complicated. So what can you and I do? Well, we should figure out who is worth listening to, podcasts. I'm going to various events, and there are numerous events these days on longevity science. And I'll mention a few which I think are pretty good. There's one in Copenhagen at the end of August, the anti-aging, I've got it wrong, AARD. Anyway, it's about drugs for anti-aging. There is one in Dublin, which I especially recommend. It's by a group that I'm closely involved with, the Longevity Escape Velocity, but it's got a remarkable number of scientists. They're not all going to agree by any means, but there's going to be a fine discussion which will generally be accessible in many parts of it to the public. So that's in that middle of August, 17th to the 20th, the Longevity Summit Dublin. There are events in New York as well, the Ending Age-Related Disease, which I have a high regard for, and there's one in Los Angeles, the Greater Los Angeles, later in the year as well, called RADFest. RADFest, Revolution Against Aging and Death. So this one has a mix of speakers. I wouldn't believe everything that I hear from all of the speakers there, but they have a fascinating mix of people who are sharing as much information as possible. So if somebody is serious about this, you've got to venture into these communities, keep your head screwed on, and keep an open mind though, and figure out for yourself what are the experiments that you want to become personally involved with, which are the treatments that you think deserve more attention, and we can work this out together. I really mean that. I don't think this is just for the so-called experts. I think people who are smart enough can learn some of the science, and you can learn some of the science from the books I've written, Abolition of Aging, The Death of Death. There are other good books out there that will help you understand some of the science, and from that point onwards, you can delve more deeply.
We're all aging, so it's probably an interest to everybody. I'd be amazed if they weren't. I'm certainly interested. And if some of those conferences you mentioned will have some of the talks open to the public online, or recordings of them,
Yes.
we can share that information and we'll put it in the information that I load with the podcast. So that would be really, really interesting. That's what I've been doing. I've been listening to you, coming to your events, and thinking more about it. We're both, I hope you don't mind, we're both the wrong side of 60. And we know that if we don't look after ourselves, that there's only one way to go. And you've said this, and I think it's really important. We are all individual, and in your book you talk about personalized medicine as well. It depends on our genetics, how we were raised, our lifestyle, our weight. So many things affect us and how we react to different treatments, and that's going to be the same for aging. So it's really, really important. So I wanted to move on now to Chat GPT. So you talked about this in the lecture to my students, and I had started that module, the new technology module, right at the beginning with engaging with Chat GPT with my students. They looked a little horrified. I think they thought I was trying to catch them cheating. I don't think it's cheating. I think with these technologies, we're here to learn. They're learning at the university. And I think we need to embrace new technologies and see how we can fit this into the learning environment. So lots of people, actually, even some of my fellow academics, don't know what ChatGPT is. So do you want to, again, we could all talk for an hour on ChatGPT. We're just going to talk for a few minutes. But in a summary, what is ChatGPT?
It's a language model that has been trained by studying vast amounts of text. So it has read huge amounts of books, it has read huge amounts of Wikipedia articles, huge amounts of online forum discussions. Increasingly, they're going to listen to transcripts of podcasts, transcripts of radio shows. So it's learning how humans tend to converse. It's learning to predict after a particular part in a sentence what's likely to be said next. And it's done this via some very clever technique called transformers, which is a particular algorithm that was invented inside Google in 2017 that enables self-supervised learning. In other words, the system no longer depends on humans to go and annotate all the data beforehand to say, this is a cat, this is a picture of a cat, this is a picture of a dog. It's able instead to search, and it will spot by itself the patterns, the ways in which pictures tend to be formed, the ways in which text tends to follow on. So it's not memorizing text and regurgitating it. Instead, it is somehow managing to abstract the patterns in pictures and abstract the patterns in text in a way that has surprised even the people who have created it. When you do enough training with enough scale, with a large enough computer system, and then ask these systems puzzles, they can work out the answers, even though the answers depend on background knowledge about the world, which is not present in your puzzle text itself. In other words, they have got increasing amounts of common sense. And often, if you're not paying attention, you can think that you're coming up with text that a human has written, but it's not from a human, it's written by this AI system. Now, the really interesting thing is that you can modify some of these general purpose systems to customize them for particular uses. And people have done this for medical purposes. So they've got the raw large language models, and they have then done fine tuning by having humans, in this case, involved at the second phase of training. So it's not the self-supervised phase in which it's learned a huge amount by itself. It's now on the human customization. So inside Google, there is a large language model called PaLM. I forget what PaLM stands for. LM is probably large model or linguistic model. And they have a system which has customized it for medical usage. And they have gone through two versions of this, MedPalm and now MedPalm 2. And what you can do with this is you can set it exams which are challenging for medical students, really challenging for medical students. And there are two types of questions. There are the multiple choice questions where there's a long question and there's maybe 9 possible answers. What's the right conclusion? I haven't a clue. When I look at this myself, it's full of medical jargon, but the system is able, in the latest incarnation, to score 80% correct, where the human pass mark's about 60. And so it's able to do this remarkably well. It's not memorizing all the questions, as I say, because you can make up brand new questions and it will still get 80% of them right. So this is remarkable. And even more interesting is a different kind of question in which you get a set of medical information and it's got to produce some text summarizing all the considerations that a patient or a clinician may bear in mind. And not only is it good at answering the first sort of questions, it is, if for many circumstances, at least as good as a normal clinician, a human clinician, at providing the advice, not just in terms of medical accuracy, but also in terms of empathy, in terms of being a human friendly, so that if you had this, you would feel as a human that your individual needs were being taken care of. You weren't just getting, quote, a robotic piece of advice. You were getting an intelligently, an emotionally intelligent robot answering you. So this is changing fast. And people say it's still not quite ready for use in the real world. But my goodness, we have a big shortage of physicians in the UK and elsewhere. We are facing larger queues than ever before. And one thing that will help is if these doctors are able to have their own capabilities augmented by advice from MedPalm 2 from Google or similar systems from elsewhere. So AI has the ability to actually leapfrog over some of the other changes I was talking about. It may be that when we reach ChatGPT 5 or 6, they will say, hang on, you humans, you're trying to solve aging. Here's a better way to solve aging. Have you thought about this? And it'll be some incredible theory which maybe one or two people have thought of, but it hasn't reached the public awareness.
Yeah, we could totally use this to save humanity, or it could be the death of humanity. We'll have to see which way it goes. Um, for any of you that
Well,
want
not
to
just
play
see, we
with
have to
this,
be involved. We have to be involved. Yeah.
Yeah, we do have to be involved.
Sorry.
For anyone that wants to play with this, if they haven't already, you can just get on ChatGPT for free. Just put it in the search engine, and have a play with it. See what it does. Ask it questions. My teenagers use it a lot. They do use it a lot to study. Hopefully, not to write their whole essay, but also apply for jobs, things like that. But yeah, have a play with it. It does depend that how you ask the question, and that's what I was getting my students to do: learn about how they need to ask phrase the question correctly. So, for example, if I ask it who's Joyce Harper, it doesn't say I don't know who Joyce Harper is. If I say who is Professor Joyce Harper, so just added one word, it tells me a lot of things about myself, which is a little bit scary. But just to illustrate that it's how you say it, really. The last thing about AI. So Geoffrey Hinton, you told us about him during your lecture to my students. I think it's someone that people should know about. He's someone people should know about.
Geoffrey Hinton is sometimes called one of the three godfathers of deep learning. Deep learning was an earlier revolution in AI. So before there were transformers, which changed the whole AI playing field, there was deep learning in 2012, which at that time changed the whole playing field and allowed a big acceleration in capabilities such as speech recognition or language translation and so on. So Geoffrey Hinton grew up in the UK, went to school in Wimbledon, studied at King's College, Cambridge, and then Edinburgh. He thought for a long time that the best way to do AI was to learn from the human brain via neural networks. He was rejected by the AI establishment for a long time, which goes back to what I was saying, that sometimes the scientific establishment gets stuck in its own blind spots. So he was told this is a waste of time, but he persisted and persisted, and from 2012 onwards, he has been recognized as a hero for persisting. And it took a while to reach that point because you needed more powerful hardware, you needed larger amounts of data for these neural network algorithms to really be widely useful. Now, what's happened more recently, he has resigned from his role in Google because his company that did this thing in 2012 was purchased by Google for a huge amount of money. You can read about that in a book, Inventing Genius. I think that's what it's called. It's not just about him, it's about a whole bunch of people who created this second wave of AI deep learning. So there is that book, and Jeff Hinton, for a while, said, right, AI's made big progress, but it's still going to take 20 or probably 50 years or more before AI seriously challenges human intelligence in a general way rather than a specific way. So it might already be better than us at translating most bits of text from one language to another, but it still doesn't really understand what it's saying. Since he's looked at not just ChatGPT, but the later version, ChatGPT 4, which, by the way, until recently at least, you had to pay a bit extra for, which is even more capable and even more intelligent, that has changed his views. And he now thinks actually the things he thought would take 20 to 50 years are very likely to happen in less than 20 years and might happen even in less than 5 years. And as a result, we've got to accelerate thinking through the consequences. What are the implications for education, the implications for jobs, and the implications of us keeping control of this, because we all see already there are bits of software running around on the internet which have caused lots of us a great deal of grief. Ransomware, malware of one sort or another. There is fake news which has been mispurposed by bad actors to change elections. And there's going to be more of it if we're not careful. And the more intelligent it gets, the more difficult it's going to be controlled. So Jeff Hinton said he has to resign from Google so he can speak publicly in a way that maybe people in Google wouldn't be comfortable with. So he's saying this is the most important subject. And it could be important in that it will lead us to the solution to aging much more quickly, or it could be more important and it will lead to the destruction of society due to us all going mad, basically, with crazy AI misleading us all and driving us into QAnon like little cults and hating each other and losing our rationality. That is a vision that's possible unless we are smart enough to guard against it. And it's not going to be obvious what to do. It's going to require a lot of thinking what to do.
Very, very important for us to talk about. whether I often say, is our future utopia or dystopia? And we're not going to know. Have you heard people say, "Why didn't anyone tell me this?" And if you have, what did they ask?
So often people are indeed interested and even shocked when they hear the ideas of transhumanism, first of all. And they say, actually, this matches what they've been thinking, but they just didn't know there was a word for it. And they didn't even know they could talk about it. They thought it might be selfish or immature to think that maybe aging is bad, because we've all been taught that, hey, it's sweet and dignified to age, and we just got to accept it. We've got to contemplate our own death and get used to it. And most people feel uncomfortable at that, but they learn to suppress that thinking a lot of the time. And when they discover there's a whole movement, a growing movement, suddenly it can change their lives. So that's part of what people have been inspired about. And then when I also point out that what's happened in technology they've already known, which is the growth of smartphones, something I was heavily involved with in the earlier years of my life, when I talk about that and people can realize, hey, that was slow and then fast. It was disappointing before it changed the world much more radically. They can realize, hey, the same thing is likely to happen with AI too. It's gone slowly and now it's going faster. It's probably going to change the world much more than even people like me tend to sometimes suggest. So that makes people wake up and change their minds as well.
Thank you. And you've been doing a huge amount of work in this area. What motivates you to do this?
Well, I'm motivated by knowledge. I'm motivated by progress. I'm most of all motivated by the wonderful things groups of humans can do. I'm a big fan of the good aspects of human nature. When we get together and produce art, produce music, produce rich conversation, produce sport, it's wonderful. And especially when we produce science and we produce new solutions. So I want to see more of that. I don't want to see this coming to an end. I don't want to see civilization itself collapsing, and I don't like it at all when individual humans go downhill and die in due course. So I'm motivated to defeat death. I'm motivated to ensure that we all have life in much more fullness.
That leads perfectly on to my next question. What makes you happy, and where is your happy place?
Well, I'm often very happy when I'm listening to a book with some ideas that stretch me and help me to see things with a deeper insight. So I love civilization, I love progress of knowledge, and when I'm part of that, I can often feel very inspired. But then, of course, we've got to see it translating into real world. And so when I see people around the world using smartphones in a very heavy way, I have a kind of a inner satisfaction because that's part of what I envisioned 25 years ago or so. That one day more and more people would use these devices, despite most people saying, nah, they wouldn't want such a device. It would be inconvenient. It would be an invasion on privacy. It would be an expensive waste of time. And I see people converting that scientific, technological, engineering insight into real world positive use. That gives me a kind of satisfaction as well.
And do you have a happy place?
It's often with books when I'm having a walk, when I may go into this internal world.
Excellent. Thank you. And your very last question, David, what advice would you give your younger self?
To realize that what takes me to a certain level in my life may not be the right thing to take me to the next level. The people that I have valued with for a while may not be the right people to spend a lot of time with in the future as well. That, yeah, we are in a dynamic, changing situation. And if we really want to come to our full potential, we've got to be able to give up in order to go up.
That's very, very good advice. Yes, I'd agree with that. Thank you very much, David. It's it's always great to talk to you. I look forward to you visiting UCL every year. And I'm going to definitely listen into some of those conferences if we can, and hopefully come along to one of your events again soon. So thank you very much for being on my podcast.
It's been a real pleasure. Thanks for having me.
Right. Woo! Right, press stop.